Today we enter the realm of classification, and so we start this out with something called binary classification. And here's the problem as is. Well, right now we've been dealing with this kind of data, where we have maybe some x-axis here, some y-axis up here, and then we have points that lie, maybe in some linear pattern like this, or honestly, even if they didn't enter some sort of linear pattern, maybe they were something more complicated, where if I was to get the same thing again, I'm not going to bother labeling the axis this time, it's still x and y, but have different points, and maybe they looked like something like this, where we had, ignore the really big one there, maybe they weren't a linear pattern, that still looks linear right now, maybe it goes up something like that, okay? So this could be a quadratic pattern because we have maybe a line that goes in like this. Maybe that's a better fit to the data. And over here, that's a linear fit. Except imagine now if our data didn't even have these sort of decimal point values. And so we're going to consider if our data actually looks like this. And it doesn't have to be actually technically a 0 and a 1. It's just we can mark one as 0 and the other as 1. On the x-axis, we can still have continuous variable, but on the y-axis, we have something that is either 0, so here it's 0, and y up here, the other possible value is 1. Okay, so maybe over here this is 1. So there's only two possible values on the y that are possible, and it would have to fall on this line or on this line. Now, a value extremely important to us as well is that of 0.5. We can picture some sort of imaginary line here at 0.5 where none of the data is going to fall except if we were to have a function which is going to be our model. Maybe we had a model that did something like this, okay? And it will actually look something like that. So that's our model, and if it's ever higher than 0.5, if it's ever higher than 0.5, well, that would mean we're going to guess it's of this class, okay? So this is, say, cat for now. These are going to be the cats, and these are going to be the dogs. Doesn't matter, don't worry about however we're encoding this information. 0 is dog, and 1 is cat, that's it. So if our guess here, which is some value that's like 0.7 or something like that, if it's higher than 0.5, we're going to assume it's towards this one class. It's a cat, and if it's less than 0.5, then we're going to assume that it's a dog right here. It's closer to 0. And that is because we're going to treat our output here, our model, as a probability. And so we can think about a probability as 100% is we can guarantee it's a cat, basically, and 0% we can guarantee it's not a cat, and since it's not a cat, we can guarantee it's a dog. So this 0.5, that represents that half chance, that 50% of I honestly don't know, it could go either way, and that makes sense. If we guess that the value is right here, that probability is right there, well then we honestly really don't know. But hopefully we have some probability that we get it to be 0.8, and so we'd assume that it's this class, even though we have 20% in uncertainty, we're not totally sure. That's at least going to be our guess is going to be this. So our model at first is going to output some numerical value between 0 and 1. Okay, so the model, we're going to say y hat is between 0 and 1. It's a probability. Okay, this is a probability. Except then what we do is to actually make our guess afterwards, what we're going to do is ask the question greater than 0.5. And so if it's greater than 0.5, we assume it's these ones. Less than 0.5, we assume it's these ones down here. Now, what we're going to end up calling this is just binary classification in general, except we're going to use what's called logistic regression. That's going to draw this type of curve for us. And so if we can get this curve, that gets this value between 0 and 1. And then we just ask the question, is it greater than 0.5? And then we'll have our answers. Now, sorry for the different picture. My app kind of broke there. What we want to do now is say with an example so that this definitely makes sense to you, is specify that this x is something. We'll say that it is the number of hairs, or basically the number of fur that's in the animal, okay? So we can measure the amount of hair that's on the animal. Maybe it fell from onto the carpet or whatever. And so now if we have this variable, we can assume that, say, actually as more and more hair is on the animal, we can assume it's closer to actually probably a dog. So we'll say that the more hair that fell on the carpet is more likely it is a dog. And so there is some sort of point here, maybe this point right here, where we'd start saying, oh, actually, if you have any more hair than this, then you're most likely a dog. We're going to start assuming that you're a dog because our prediction is going to be better than 0.5, and so we'll assume that. Otherwise, we'll assume the opposite, and if it's less than that, if it's less than this value of x, then we're actually going to assume down here, you have some probability that's less than 0.5, we're going to assume that you're a cat instead, okay? And so I interchanged what is dog and cat up here. You can do that, it doesn't really matter. It will change the look of your data set, but it's not going to change inherently what the data actually represents.